Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is AQA 2021, paper 2, higher tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1. Circle the factor of x squared minus 5x. Now you might be initially a little bit confused by this, because if you look at the terms x squared and 5x and think about, well, what's a factor of both those numbers? Well, a factor would be x. They have x in common, don't they? So I could take x out. But x is one of the answers on my list. The closest I've got is 5x, and 5x is definitely not a factor because 5 doesn't go into x squared. So what's going on here? Well, if I did factorize x out of this expression, then I would get x left inside the bracket, wouldn't I? And I would get 5 left inside the bracket. So this factorizes to x minus 5, okay? So it's pretty easy to see that x is a factor, but perhaps it's not so clear to see, immediately to see, that x minus 5 is also a factor. Factors of numbers are things that multiply together to give you your number, don't they? So if you think of the factors of 6, 2 is a factor, and therefore 3 is a factor as well, because 2 times 3 is 6. So here, if x is a factor of x squared minus 5x, and x times x minus 5 is x squared minus 5x, then x minus 5 must also be a factor, and that is the one I'm looking for then, isn't it? Question 2, a is half of b. Work out the ratio of a to b. Circle your answer. Okay, now this is actually, converting an equation involving a and b into a ratio involving a and b. Now this little bit at the top here, a is half of b, we can rewrite as saying a equals half of b. So half of b like that, or a equals b over 2. Multiplying both sides by 2, I'm going to get 2a equals b then, aren't I? That's the relationship between a and b. Okay? So if 2a is equal to b, then b is going to be equal to 2 lots of a then. So if I made a 1, then b would be 2 lots of 1, b would be 2. So the ratio of a to b is 1 to 2. Now these kind of confuse students quite a lot, because if you have a look on which side the numbers are, like in the ratio, the 2 is sitting under the b here, is it? It's the b that has a value of 2. But in the equation, it's the a that has the 2. Okay, and the other way around as well. In the ratio, a is 1 and b, well, you've got 1b there, haven't you? So you've got the 1 there. So they kind of switch around when you move from equation to a ratio, and that does confuse people. But it is what it is. It's 1 to 2. Question 3. The first 3 terms of a geometric progression are 2/3, 4/9, 8/27. Circle the fourth term. Now, a geometric progression is a type of sequence where the next term in the sequence you get by multiplying the previous term by a number. Okay, we say it has a constant ratio, so next term is always a constant ratio multiple of the previous one. So what is that common ratio? Well, let's have a think about it. What would I need to multiply 2/3 by to get 4/9? Well, you can see if I multiply 2 by 2, I'm going to get 4. And if I multiply 3 by 3, I'm going to get 9. So if I multiply 2/3 by 2/3, I'm going to get 4/9. Now, is that the same for the next one? If I multiply this by 2/3, then 4 times 2 is 8, and 9 times 3 is 27. So that seems to work as well. So I should be able to get the fourth term by multiplying through by our common ratio of 2/3. So 8 times 2, well, that is 16, and 27 times 3, that is equal to 81. Okay? So this is a progression with first term 2/3, common ratio of 2/3, and that makes the fourth term 16/81. Question 4, circle the reason why these triangles are congruent. Well, let's have a look at the triangles. I've got a side length 5 here. That matches with one on this side of 5. I've got a length of 8 here. That matches with this one. And I've got a length 9, and that matches with that one. So basically, all the sides match up, don't they? Okay, all three sides of these two triangles are equal, making them congruent. And the rule then is side, side, side. That one there. Question 5, solve 10x equals 62.4 minus 3x. Okay, now the first thing I notice, I've got x's on both sides here. So I'm going to collect them together first by adding 3x to both sides. Okay, so that's going to give me 13x equals 62.4 then, isn't it? So it should just be a matter now of dividing both sides by 13 to find out what x is. So what's 62.4 divided by 13? Can't do that in my head. I'm going to grab a calculator, I think. 62.4 divided by 13, that comes to 24/5 or 4.8. So x is 4.8. Question 6. Lines A, B, C, and D and E intersect as shown. Lines A and B are parallel. Work out the size of angle X. Okay. I'm just going to mark our parallel lines because it's easy to get confused otherwise with your alternate and corresponding angles and things. Okay, so it's got a bit of a veritable forest of lines going on here. Now we're trying to get this x here, but these sort of questions, you don't overly focus on the thing you're going to find. Just kind of work your way around the diagram, really. I think what I'm going to try and do is I'm going to try and work out the angles in this triangle, okay, and then use angles in the triangle to find x. So that means I need to find this angle down here, and I need to find this angle over here then, don't I? Okay, so how am I going to do that? Well, I can spot one of them first off. This one up here is corresponding, isn't it, to the blue one down there. So we can say that this one over here is 49 degrees as well. Okay, what about the little pinky one there then? How am I going to work that one out? I think I'm going to do that in 2 bits. I can see that this angle up here, look, 110, that is alternate to this big angle here, which is going to be 110 then, isn't it? All the way across here. And I also know that these two angles are vertically opposite. So that one in there is 52. So then this angle here has got to be 110 take away 52, isn't it? So this one, it's a bit of a colour disaster in there now, isn't it? Sorry about that. So thinking about that angle in there, look then, that one is going to be the 110 minus the 52 then, isn't it? Okay, so 110 minus 52, that's going to be 58. Okay, so that angle is 58, and now we've got angles in the triangle, haven't I? Because I've got 2 of the 3 triangles, so I can use x plus the 58 plus the 49, and say that's going to be equal to 180 because angles in a triangle add up to 180 degrees. So then just add in those two together first, 58 and 49, that comes to 107. So I'm going to get x plus 107 is equal to 180. And then taking 107 away from both sides, x then is going to be 73 degrees. Okay, so I got x is 73. Question 7, 102 boys and 85 girls took a test. The table shows information about the mean marks. So I've got number of students, I've got 102 boys and 85 girls, and their mean marks are 68.5 and 72.4. The pass mark for the test was 70. Was the mean mark for all of the students greater than the pass mark? You must show you're working. Okay, so basically we need a kind of total amount, don't we? Okay, so if I know that the mean mark for the boys was 68.5 and I know that the number of students was 102, then I can use that to work out the total marks, okay, for boys. So the total mark for boys is going to be those two multiplied together then, isn't it? So if I type into my calculator 102 times by 68.5, that comes out to be 6,987. 6,987. And do the same thing with the girls. 85 times 72.4. That comes to be 6,154. Okay. And then I'm going to total this way as well then. Total for boys and girls then. This is going to be my boys and girls column. Let's call it B's and G's. B's and G's. Okay, so what's the B's and G's? How many B's and G's do we have? We have 102 plus 85. So we've got 187 B's and G's. We want to work out their mean mark. I know their total marks must be those two totals added together. So if you add those together, 6154 plus 6987, then I know that B's and G's together scored 13141. 13141. Okay, so then I can now work out the mean mark then, can't I? I can say that the mean is going to be the total scores for the B's and G's, 13141, divided by the number of B's and G's, 187. What's that then? Divided by 187, that comes out to be 70.27 reoccurring. Just going to round that off to 70.3. Okay, so was the mean mark for all of these students greater than a pass mark? Yes. Overall pass mark exceeds 70 marks. Question 8. Describe fully the single transformation that maps triangle ABC to triangle ADE. Now just take care of the way around this goes. We are mapping the big triangle ABC onto the little triangle, aren't we? Okay, not the other way around. It's clearly an enlargement, but because you're going from the big one to the small one, it's going to be an enlargement with a fractional scale factor. Okay, so I'm going to write down that it's an enlargement. Now, with an enlargement, we need to state two things. We need to know the scale factor, which we think is going to be a fraction, because it's kind of a reduction rather than an enlargement. And we need to know the center of enlargement. Now, I can spot that already. But if you're not sure where it is, what you can do is you can take matching points on object and image. And this point here would match up with this one. And this point here would match up with this one. And you can join them up with straight lines, and that will pass through your center of enlargement, which you should spot ends up being the point A, doesn't it? Okay, but actually I spotted that straight away because A maps to A. Okay, so if it's an enlargement and a point maps to itself, then that point has to be the center of enlargement anyway. That's the only point that doesn't move in an enlargement, is the point on the center itself. So you should be able to spot that A is the center of the enlargement of this shape. Okay, so this is an enlargement, center, point A, which has coordinates 3, 9. And what is the scale factor? Okay, well, if we find matching lengths on object and image, probably easiest to use this one. Look, this one here is 4 units. This one here goes from half to half, doesn't it? It's actually 1 unit. Okay, so it's a quarter of the size. So the scale factor is going to be 1/4. All right. So enlargement center 3, 9, scale factor of 1/4. Question 9. A ball contains 5,000 cubic centimeters of air. More air is pumped into the ball at a rate of 160 cubic centimeters per second. The ball is full of air when it becomes a sphere with radius 15 centimeters. We've been given the volume of a sphere formula. It's 4/3 pi r cubed, although probably it's just as easy to remember that, where r is the radius. Does it take less than 1 minute to fill the ball? You must show all your work in. Okay, so what we're going to have to do here is we're going to have to find the volume of air inside the ball when it's fully inflated. And we're going to then see how much extra air was put in. And then we can use that to work out how much time that took. And then we can see if that amount of time is less than a minute or not. And that's my kind of plan of action. Okay, so let's find the max volume of the ball then. So maximum volume. We were told the maximum volume occurred when the radius of the sphere was 15 centimeters. So the max volume is going to be 4/3 pi r cubed when r is 15, then, isn't it? So that's 4/3 of pi times 15 cubed. Okay, so what's that? Just going to do the number part for now. I'm just going to leave it in terms of pi. I'll do that on the final calculation. So what's 15 cubed times 4 divided by 3? That's 4,500. So I'm just going to leave it as 4,500 pi. If I multiplied pi by pi here, I would just have like a decimal that I had to use all the way through, and I'd lose more accuracy. So it's better to leave it as an exact value like that for now. Okay, so then the ball contains 5,000 cubic centimeters of air to start with. So then the change, or the amount of air put in, so the air added, is going to be the difference between 4,500 pi minus that 5,000 cubic centimeters that was already there. Okay, so that's how much air was added. Again, I'm just going to leave it like that for now because, yeah, pi. And then what's next? I know that air was going in at 160 cubic centimeters per second. So time taken then, is going to be that 4,500 pi minus 5,000 over 160 then, isn't it? Okay, and that'll tell me the number of seconds. Now I am going to work it out with the pi this time, because this is my final calculation. So 4,500 lots of pi minus 5,000, and then that divided by 160. Okay, that comes to 57.1 on my calculator, to 3 significant figures. So that's 57.1 what, seconds? Okay. Does it take less than a minute to fill the ball? Yes. Yes, it does. Yes. It takes 57.1 seconds, which is less than a minute. Okay, so I'm done. Question 10. P is a positive number, N is a negative number. For each statement, tick the correct box. Okay, and I've got an always true, sometimes true, and never true for each statement. They all got a bit wonky when I printed them out for some reason. But basically there's one box for each, isn't there? Let's have a look at the first one. P plus n is positive. Is that always true? Is that sometimes true? Is that never true? Well, I think with these, sometimes it's helpful to have some test values. So if I let P equal 2, say, and I let n equal 3, then I can see that if I added those, sorry, minus 3 because n is negative. So if I had p is 2 and n is negative 3, then 2 plus negative 3, that is a negative number, isn't it? Okay. However, if I'd have picked 3 plus negative 2, then that would be 1. Okay, so for that one, you sometimes get a positive number when you add p and n together, but you don't always. You sometimes get negative ones. So that one is sometimes true. What about p minus n? Is that always positive? Well, using the same numbers, look, 2 minus negative 3, those two minus would become a plus, and that would be 5. 3 minus negative 2, that would also be 5. Is that always true? Does it matter? Okay, well, taking away a negative is always positive, isn't it? So this becomes like a positive number plus another positive number, and that is always going to be a positive number. Okay, so I think that one is always true. P squared plus n squared, is that always positive? So again, with our test values, 2 squared plus negative 3 squared, that's going to be positive, isn't it? Because 2 squared is 4, negative 3 squared is 9. Add them together, you're going to get 13. So that's positive. If I had 3 squared and I added on negative 2 squared, another example, that's the same value. Because when you square a negative, you always get a positive, don't you? Okay, so a negative squared is always positive, and again we're going to have a positive plus a positive, and that is always then going to be a positive. Okay, so that one is also always true. P cubed divided by n cubed. Okay, now in this case, when you cube a number, it retains its sign, doesn't it? So if you cube a positive number, you get a positive number. But if you cube a negative number, you still get a negative number, because a negative times negative is positive, and times a negative again gives you a negative number again. So again, with our test values, if I had 2 cubed and then I divided it by negative 3 cubed, that would give me 8 over negative 27, which would be a negative number. If I had 3 cubed divided by negative 2 cubed, then that would be 27 over negative 8, and that would be negative. So is it always negative? Well, this one is always going to be positive, isn't it? And this one is always going to be negative. So you're going to get a positive over a negative, and that is always negative. So that is never true, that one, because you always get a negative number. Question 11, 250 trains arrived at a station. The number of trains that were late was recorded after every 50 trains. The table shows some information about the results. So we've got the number of trains along the top, 50, 100, 150, 200, 250, and the number of late trains out of those amounts, 16, 21, 36, 38, 55. And along the bottom, we've got relative frequency calculated for 2 of the 5 values. Then part A says complete the relative frequency graph. Okay, now in order to complete the relative frequency graph, we need to complete the table first, don't we? Now you'll see that 0.32, the first relative frequency there, you can get by dividing 16 by 50. That gives you 0.32. And 0.21 is 21 over 100. So the next value in that table is going to be 36 divided by 150, which comes out to be 0.24. Okay, and then the next one is going to be 38 divided by 200, which comes out to be 0.19. And finally, I'm going to get 55 over 250, which is 0.22. Okay, so now I've got all my relative frequency. Now I can plot the relative frequency graph. Okay, so we can see that the relative frequency started at 0.32. It went down to 0.21. And then at 150, it bobbed up again to 0.24, which is going to be here. Note you've got 10 divisions on my graph between 0.2 and 0.3, so it's going to be 4 little squares up. Okay, next one, I'm going to have it 200 trains. I've got a relative frequency of 0.19, so that falls down a little bit again, and then it recovers a little bit. For 250, it goes back up to 0.22, which is there. Okay, so I'm going to join those up with a ruler. Now with relative frequency, your accuracy is going to improve as you increase the number of trials. So you do get this kind of jumping around as you add more and more trials. Now what should happen is that your relative frequency gets closer and closer to the true value, the true probability of that event occurring. Okay, because the more trials you have, the more data points you've got and the more accurate your result is going to be. Okay, so I would say the earlier trials are more inaccurate, and the last one there, that 250, is the most accurate relative frequency you have from the data, because it involves the most data points. Right, now part B says write down the best estimate of the probability that a train arriving at the station is late. Oh, okay, I just kind of answered that. Didn't know that was going to be the question, but it's that last one there, isn't it? The final point on the graph is the best estimate of probability, so it's going to be 0.22. Question 12, A, B and C are 3 points on a circle. The radii from A, B and C are shown. Is AC a diameter of the circle? You must show your working. Okay, so it's not drawn accurately, but we've got 3 angles given, and we need to see if 5x plus 40, then this one here resolves to 180 degrees. And if it does, then AC is going to be a diameter. But if that angle is not 180 degrees, then it's not a diameter, is it? Okay. Now we've got 3 angles meeting at a point, basically. So we've got 5x plus 40, we've got x, and we've got this 2 lots of 2x plus 20. Okay, and we know that angles meeting at a point sum to 360. So angles meeting at a point sum to 360. Okay, so that means those 3 angles added together should be 360 degrees. So the 5x plus 40 plus the x plus the 2 lots of 2x plus 20. So the yellow one, the green one, and the blue one added together should be 360. Okay, so let's try and collect everything together. Before I do that, I'm gonna have to multiply out this bracket here, aren't I? Okay, so I might collect the 5x and the x together. So that's 6x plus 40 plus, I've got 2 lots of 2x, which is 4x, and I've got 2 lots of 20, which is 40. So that's equal to 360. And then I've got my 6x and the 4x, and I've got 40 and 40. So adding those together, that gives me 10x plus 80 equals 360. Okay, so I've got a linear equation in x. Let's go on and solve it. Let's take 80 away from both sides to start with. That will cancel, and it'll leave me with 10x on the left. 360 minus 80, That's 280, isn't it? So then if I divide both sides by 10, cancel, leaves me with x is equal to 280 divided by 10, that is 28 degrees. Okay, now I've not answered the question, have I? The question was, is the yellow angle a straight line? So therefore AC is a diameter. So if x is 28, then 5x plus 40 then is going to be 5 lots of 28 plus 40. 5 lots of 28 is 140, plus 40 is 180. Okay, so that means that that angle is 180 degrees, which means AC must be, therefore AC is a diameter. Question 13, a straight line has gradient 6 and passes through the point 319. Work out the equation of a line. Give your answer in the form y equals mx plus c. Well, I'm actually going to start with that, y equals mx plus c. That's the general form of an equation of a straight line, isn't it? And I already know something about this straight line. I know it's got a gradient of 6, so I already know that number there. So I'm going to say let equation be y equals 6x plus c. So then the only thing I don't know then is the c, isn't it? I do know it passes through a particular point, 319. So subbing in x is 3, y is 19 into that equation, so 19 equals 6 lots of 3 plus c. Because I know those 2 points go together, I know that this equation holds for those 2 values. So if I sub them in, then the only thing I don't know is c, isn't it? So 19 equals 18 plus c. So taking 18 away from both sides, I can see that c must be equal to 1 then. Okay? And now I've got everything. I've got the y-intercept, which I know is 1, and I've got the gradient, which I know is 6. So I've got the equation of line, haven't I? Equation of line is y equals 6x plus 1. Question 14. The population of butterflies in a park is 4,200. Part A says, assume that the population increases by 12% each day. Show that after 20 days the population would be greater than 40,000. Okay, so this is a growth and decay problem, which is pretty much the same thing as compound interest, isn't it? But with butterflies rather than pounds in the bank. Okay, so we're going to be doing it using our little triangle FOM, which I use for all percentage questions. Okay, and then we just need to work out what F, O, and M is here. Right, the final is the final population of the butterfly. So that is what we're going to be finding. The original is the starting population of the butterflies, which is up here, look. So O is going to be 4,200. 4,200. What's M? M, the population increases by 12% each day. So that's going to give us our multiplier. Now with percentage increases, we always start with 100%. I'm going to add on 12%. That gives us 112%, which as a decimal is 1.12. Okay? So what do we do now then? We want to find the final. So cover up the thing you want to find on the triangle, put your thumb on it, and that tells us what to do with the other two. Final equals original times by multiplier. So final equals original times by multiplier, okay, which is 4,200 times by 1.12. But then that's if we did it once, but we need to do it a number of days, don't we? So we need to keep applying this this multiplier. We need to apply it 20 times. Okay, so we're going to raise that to the power of 20 there. Okay, so that we raise it there. So 4,200 times 1.12 raised to the power of 20. 4200 times 1.12 to the power of 20. That comes to 40,514 butterflies. And one looks like a squidged one, 0.43099 of a butterfly. Let us not dwell upon part of butterfly. 40,514. Okay, so show that after 20 days the population would be greater than 40,000. Population is 40514, which is greater than 40,000. Job done. Question 14b. In fact, the population increases by 13% each day for 19 days and then decreases by 8% for 1 day. After the 20 days, is the actual population greater than 40,000? Tick the box. Yes stroke no. Show your working to support your answer. So rather than what we had before of 4,200 times 1.12 to the power of 20, instead what we've got is we've got an increase of 13%. That's going to change my multiplier from 0.12 to 0.13, isn't it? So that's going to change. And then I'm only going to apply it now 19 times rather than 20. Okay? But I am going to apply an additional multiplier where it decreases by 8% at the end. So a decrease of 8%, what's that? If you start with 100% and you subtract 8%, you are left with 92%, which is 0.92 as a multiplier. So I'm going to multiply at the end, my last year, I'm going to multiply by 0.92. Okay? So the population is 4,200, the starting population, times by 1.13 19 times and 0.92 1 times. What's that then? So 4200 times 1.13 to the power of 19 times 0.92. So that comes out to be 39,402.8. I'm going to round that up to 39,403 butterflies. Okay, because I can't deal with parts of butterflies. Okay, so what's the question? Is the actual population greater than 40,000? No. Population is less than 40,000. Okay, so the population is less than 40,000. Part C says the expected number of visitors to the park each day depends on the temperature. So when the temperature is less than 21 degrees, they get around 700 visitors each day, and when it's 21 degrees or more, they get 900 visitors per day. On each of the 30 days in June, the park is open, and the probability that the temperature is less than 21 degrees is 0.4. So work out the total number of expected visitors to the park in June. So we can use expectation here, can't we? So we can use the expectation, the expected number of cooler days is going to be the number of days, 30, times the probability of success. It's 0.4, isn't it? So what's 30 times 0.4? 30 times 0.4. So we're expecting it to be one of the cooler days for 12 days. Okay, so 12 days it's going to be cooler, and therefore then on the rest of the days, so warmer days, it's going to be 30 minus the 12 cooler ones, which is 18 days. So we're expecting 12 cooler days and 18 warmer days. Okay, so then how many visitors are we expecting then? So visitors is going to be 12 days at the lower number then. The cooler days we're expecting 700 each day, plus 18 days where we've got the warmer temperature going on, and we're expecting 900 people for each of those. So what is 12 times 700 plus 18 times 900? That comes out to be 24,600 visitors. 24,600. Question 15. L is directly proportional to d squared. L is 85 when d is 10. Work out an equation connecting L and d. Okay, so let's do that then. I like these questions. I think they're very, very formulaic. They're always the same, and once you've learned the technique, you can definitely get all the marks. Let's start with the first statement. L is directly proportional to d squared. So we can write it down then with our proportionality symbol. L equal fishy d squared. L is directly proportional to d squared. Okay. Then we can replace our L is little fishy d squared. We can replace little fishy with equals k. So that becomes L equals k lots of d squared. Then all we need to do then is to work out what k is. Now handily, they've given us a pair of values that go together. Now they give you these so you can work out what k is, that constant of proportionality. So when L equals 85, d is equal to 10, that tells us then that 85 is equal to k lots of 10 squared. Okay, 10 squared, that's 100, isn't it? So that's 85 is equal to 100 lots of k. So then that means that k is equal to 0.85, and isn't it, if you divide both sides by 100. Okay, so we've got our constant of proportionality, and therefore the equation linking L and D together is L equals 0.85 lots of D squared. Okay. Part B says work out the value of L when D is 5. Remember that L is equal to 0.85 lots of D squared. So when D is 5, what's L then? L is going to be equal to 0.85 lots of 5 squared. Okay, so what's that? 0.85 times 5 squared, that comes out to be 21.25. So L is 21.25. 21.25. Question 16. Here is a cube with edge length x centimeters. One diagonal is shown. Part A says circle the length in centimeters of the diagonal. Okay. Now, diagonals in cubes or cuboids come up often enough for you to remember the formula for it. There's a variant of Pythagoras theorem for cuboids. So in 2 dimensions, and you've got a right angle triangle, you know that c squared equals a squared plus b squared, don't you? Where a and b are the 2 shorter sides of your triangle, and c is the longer side. So that's Pythagoras theorem. Now when you've got a cuboid and you want to know the length of the diagonal in that, okay, there is a related formula. Let me just kind of show that a little bit clearer. Okay, so there's a related formula. It says the length of the diagonal, which I'm going to call d squared. So let's say this cuboid had length x, width y, height z. Then d squared then would be x squared plus y squared plus z squared, or d is equal to the square root of x squared plus y squared plus z squared. Okay, so like I say, it comes up enough, I would say, to memorize this really. You can do it just by applying Pythagoras theorem twice. You can make a triangle here and work out the length of that hypotenuse after you have applied Pythagoras theorem to this triangle and worked out the bottom line there, because you've already got that one. So you can just apply Pythagoras theorem twice, but knowing the formula kind of jumps over all of that. You can just go straight to using the formula. So d equals root x squared plus y squared plus z squared. In this case, it's a cube, not a cuboid. So x, y, and z are all the same, aren't they? So what you've got here then for a cube, for the cube, where all the sides are the same, then d is going to be equal to the root of x squared plus x squared plus x squared, because all three sides are the same, which is the same thing as the root of 3x squared. So it is, which one? Now I don't see that one matched down there, but we can break this one up a little bit more. We can reformulate this a little bit. We can say that the root of 3x squared is the same thing as the root 3 and the root of x squared. So that is the same thing as the root 3 of x. So I believe it is that one there at the front. Okay. Not a nice way of writing it, but anyway, I prefer to write as the root of 3x squared, but yeah, on there it's that way around. 16b, the total length in centimeters of the edges of the cube is a multiple of 18. Circle the correct statement. X is a whole number, x is not a whole number, x might be a whole number. Okay, the total length in centimeters of the edges of the cube. How many edges does a cube have? Okay, let's just think about that. So if I've got a cube, better show all the sides, didn't I? Okay, so then how many edges does it have? It's got 1, 2, 3, 4 along that face, 5, 6, 7, 8 looking at the edges of that face, and then you've got 9, 10, 11, 12. So you've got 12 edges altogether. 12 edges. Okay. And 12 edges, if you add up the total length in centimeters of the edges of the cubes, you get a multiple of 18. Okay. Is x a whole number? Is x not a whole number? Is x might be a whole number? Okay, well, if the total is 18, okay, let's say that the total was 18, the first multiple of 18, and you got 12 edges, then each edge is going to be 18 divided by 12. It's going to be 1.5. Okay, that's not a whole number, is it? Okay, so it's definitely not this first one here. It's definitely not a whole number all the time. But let's think about the next multiple of 18. The next multiple of 18 is 36. Now 36 divided by 12 is a whole number. That is 3. So that means it's not always not a whole number. It's that one. It might be a whole number. Okay, because I've got two examples there. One when it's not a whole number and one where it is, for two different multiples of 18. So that's going to continue, isn't it? The next multiple is not going to be divisible by 12, and the one after is. Okay, so x might be a whole number. Question 17. 20 people are asked which device they used more often, their laptop or their phone, and the table shows the results. For males, 2 used their laptop most and 9 their phone. For females, 4 used their laptop most and 5 their phone. I would contest that data, but anyway. 1 male and 1 female are chosen at random. Work out the probability that exactly one of them said laptop. Okay, let's first work out the probability of individual males and females saying laptop then. So the probability that a male says a laptop, that is going to be the 2 males who had laptops divided by the total number of males. Now, if you've got 2 with laptops and 9 with phones, that's 11 altogether. So the probability that a male says laptop is 2/11. Now, the probability that a female says laptop is the 4 who said laptop out of the total of 9. Okay. Now we know that, we want to work out the probability that exactly one of them said laptop. Okay, I'm going to do that in a little kind of tree, like a probability tree. So let's do the male choices first. So this is the male, and then we'll do the two branches for the female choices. Okay, so assuming that the male said laptop here and not laptop there, and laptop, not laptop, laptop, not laptop. Okay, so the probability that the male said laptop was 2 in 11. So the probability that the male didn't say laptop was 9 over 11. Okay, the probability that the female said probability that the female said laptop was 4 over 9. So the probability they didn't say laptop was 5 over 9. And that's going to be repeated down here because they're independent. Okay, so then we're interested in exactly one of them said laptop. So the probability of exactly one, that is going to be either that the male said laptop and the female didn't, or it's going to be that the female, the male didn't say laptop, but the female did. Okay, so it's those two branches, isn't it? So it's going to be the branch laptop, not laptop, or, which is plus in the land of probability. I'm just going to move this over because I'm kind of busting out the edge of the screen here. So let's just move this over to the side a little bit because I ran out of space. Tum-tum-tum-tum-tum. Let's just move it that way a little bit. Yeah, that fits better. Okay, so the probability of exactly one was probability of laptop for the boy, not laptop for the girl, plus the probability of not laptop, laptop then. Okay, so probability of laptop, not laptop, that's the yellow root. Okay, and that is going to be 2/11 times 5/9. And then probability of not laptop, laptop. So boy not laptop, girl laptop. That was going to be the green root. So that is 9 over 11 times 4 over 9. Okay, so what's that then? Calculator, what is 2/11 times 5/9 plus 9/11 times 4/9. That comes out to be 46/99. Part B says two males are chosen at random. Work out the probability that they both said phone. Now this is going to start out the same way, isn't it? With males either choosing laptop or not choosing laptop. In other words, choosing phone. Okay, and the probabilities are going to start out the same. We've got 2 out of 11, don't we, who chose laptop, and 9 out of 11 who didn't. But then on the second selection, remember that you've already picked one of the guys, haven't you, to ask. So then if you're going to pick again, you're going to have different probability outcomes depending on what happened first time round. So let's assume you picked one of the guys who preferred working on their laptop. When you ask the next set, you've got one less to pick from of people altogether, and one less person who chose laptop because you've already picked one earlier, and the same earlier for the second fraction. You're going to have out of 10 there, and you've still got all 9 to pick from there. Okay, so then in the second route, if I pick not laptop first time round, I've still got the 2 guys who preferred laptops to pick from, but then that is out of 10, and I've got one less people who didn't like laptop out of 10 in that direction. So that's laptop, not laptop, laptop, not laptop. So then the probability of both phone, just one route through, isn't it, this time? That means not laptop, not laptop. So it's going to be the 9/11 times 8/10, which is what? 9/8 is 72. 2, 11 tens are 110, sorry, so that's 72 over 110. Question 18, on the grid, identify the region represented by x is less than or equal to 5, y is less than or equal to 4, and x plus y is greater than 6. Okay, right, first up, I've got x is less than or equal to 5, so I'm going to draw the line x is equal to 5 then. So what's x is equal to 5? That is a straight line, isn't it? Which is parallel to the y-axis, or vertically straight up. It's another way of thinking about it, passing through the number 5. Okay. Now notice it's less than or equal to, so we're going to use a solid line for this one. And the reason for that is every point on this line could be part of the region because it's less than or equal to 5. Okay, so we've done x is equal to 5. Now the next line we need to plot is y is equal to 5. Sorry, y is equal to 4. Now the line y is equal to something is a horizontal line passing through that value. So we're going to have a straight line passing through 4 then, aren't we? Again, it's a solid line because it's less than or equal to 4. Okay, then finally I want to plot the line x plus y is equal to 6. Just rearranging it so it's the form y equals mx plus c. Y equals then 6 minus x. So that gives me a y-intercept of 6 then. C is the y-intercept. And the gradient is the coefficient of x, which in this case is -1, isn't it? So m is -1. Okay, so I'm going to plot those points using a y-intercept of 6 and a gradient of -1. Now you could do a table of values for this. You could just take your values for x along the bottom, 0, 1, 2, 3, 4, 5, 6, sub them into the formula, into the equation and work out the coordinates. I just like to use the intercept and the gradient to draw my lines. So I know if it passes through, if it's got a c value of 6, then it's going to go pass through the y-axis there, isn't it? That's what the y-intercept means. Now the gradient is -1, which means for every 1 unit you go along, you go 1 down. So I'm going to have another point there, and another unit along, another unit down. We're going to have another point there, and so on. So I'm going to get this diagonal line passing through all of these points going that way. Okay, just get rid of my little dots there. And once I've got all those points plotted, I can just join them up with a line. Now this time x plus y is strictly greater than 6, so the line itself is not part of the region. So I need to use what we call a broken line through here, kind of a dashed line. Okay, to show that the line itself is not part of the region. Okay. Now those 3 lines divide up your grid into various sections. I've got like a section here, I've got a section here, I've got a region up here, they're called. I've got a region down here, I've got like an ecoregion in there, I've got a big region here, and I've got one in the middle there. Now often it's the one in the middle of all 3 lines, but it's not always the case, but usually it is. So that's where my first guess is going to be, that it's going to be in that triangle in the middle. So what I'm going to do is I'm going to pick a point that lies in that area. Here's a point here, that's solely within the region, isn't it? And now that has coordinates, so I want to test point, what's the coordinates of that? 4, 3. Test 4, 3. Now, if x is 4 when y is 3, does that mean that x is less than or equal to 5? Yes, well, the x coordinate is 4, and 4 is less than 5. So that one works for that particular point. Okay? Is my y coordinate less than or equal to 4? Well, my y value is 3, so 3 is less than or equal to 4. So again, this one is true for 4, 3. And then finally, is x plus y greater than 6? So if I take my x value 4 and I add on my y value 3, add it together, is that more than 6? Well, yes it is, because 4 plus 3 is 7, so that one is true as well. Okay, so in this case, all three of my inequalities are true for that coordinate 4, 3. So that means I've found a point within the region, and that means my region is that area between those three lines there. So I'm gonna shade it, and I'm gonna label it R. Okay, so I'm just gonna shade that, and I'm gonna label it R as requested. Don't forget to label it R, because you will lose a mark if you don't do that, and it'll be really irritating for you. Okay, so R is there. Now, if any of those had not been correct, if you found one was not true, then you would pick again another region. So you try and pick one the same sort of on the same side of the lines as the ones that are true, and then switch to the other side of the line for the one that's false. And you should be able to zoom in fairly quickly in a couple of guesses which region you're in. I got lucky first time, so I'm moving on. Question 19. The graph shows the height above ground of a toy rocket for 10 seconds. Part A says, for how long is the rocket in the air? Circle your answer. Okay. Well, the rocket is in the air when the height in meters is above 0, isn't it? And that is for this time here. Okay. So between 4 and 10 seconds. So 10 subtract 4. That's 6, isn't it? So I believe it is in the air for 6 seconds. Now, part B says, using the graph, estimate the speed of the rocket after 6 seconds. State the units of your answer. Okay, so after 6 seconds, this is the point on the graph for t is equal to 6, isn't it? Okay. Now, it's a curved graph at this point. Now, generally, if you've got a distance time graph and you want the speed, then you need to find the gradient of the line, isn't it? So speed is equal to gradient of dt graph, distance time graph. Okay, so the gradient of this distance time graph will give you the speed, but we have got a curve, and finding the gradient of the curve is a little bit more tricky than the gradient of a straight line. So what we need to do first up is to draw a tangent to our curve. So if you take a ruler and you just kind of nudge it up against the curve so it just touches the curve at the point you're interested in, which I already marked on the diagram. Now that is what we call a tangent to the curve. Okay, we're going to draw that on. So that's my tangent. So then, because I haven't got a straight line, I'm going to work out the gradient of the tangent rather than the gradient of the line, because I haven't got a line. So what I'm going to do is I'm going to pick 2 points on that tangent that I can easily read. I think I'm going to pick this point down here at 2, 0. And I'm going to use change in y divided by a change in x. So the speed is equal to the gradient of the dt graph, which is equal to the gradient of the tangent drawn at the point of contact. Change in y then, so change in y would be this height here. So we want that value, and we want change in x, don't we? We want this value here. Okay, so change in y, well that is 8, isn't it? The height of that bar there is 8. Change in x from 2 to 6 is 4. So then the gradient is going to be change in y divided by change in x, which is going to be 8 divided by 4. It's got a gradient of 2. Okay, so then the speed is equal to 2. 2 what? Well, the height's in meters and the time is in seconds, so the speed is in meters per second. So 2 meters per second. Now it does actually say state the units of your answer there, so that is actually worth a mark for getting that bit right. Okay, so don't forget that bit, meters per second. You can also write it as 2 meters per second to the -1. That's an alternative way of writing per second. Okay, because if you think about it, s to the -1 is 1 over s, so it'd be m over s. Same as before. Question 20. A square has an area of 0.25 square meters. Circle the length in centimeters of one of the sides of the squares. Now notice the switch of units here. This is in meters, this is in centimeters. Okay, so we've got a square, okay, and we know that its area in here is 0.25 square meters. So how many square centimeters are there in a square meter? Well, if you think about it, if you've got a square which has got 100 centimeters this way, that's 1 meter, and 100 centimeters that way, that's 1 meter. So a meter by a meter square will have 100 times 100 square centimeters inside, which is a 1 followed by 4 zeros, isn't it? What's that? 10,000. So it's got 10,000 cubic centimeters, 10,000 square centimeters in a square meter. 100 times 100. Okay, so if I times 0.25 by 10,000, 0.25 times 10,000, that tells me that I've got 2,500 centimeters squared inside my little square. Now if it's a square, then both sides are the same, so that's going to be L times L. So then L squared is equal to 2,500. So what's L then? It's going to be the square root of that, isn't it? So what is the square root of 2,500? 2,500 all square rooted. That comes out to be 50. So then L is 50. It's that one, 50 centimeters. Question 21. X is an integer. Prove that 35 plus 3x plus 1 all squared minus 2x lots of 4x minus 3 is a square number. Okay, well I think what we're going to have to do here is multiply everything out, collect all the like things together, and see if we can express that as a square. Okay, that's the plan. Okay, so let's do some multiplying out and stuff. So I've got 35 at the front, and then I've got 3x plus 1 all squared. When you square something, you times it by itself. So that is 3x plus 1 times 3x plus 1. Don't just square 3x and 1. You will get it wrong. Okay, and then minus, I'm going to do this while I'm here, 2x times 4x and 2x minus 3. That's going to give me minus 8x squared, and negative 2x times negative 3 is positive 6x. Okay, so then I've got a FOIL that I can do on these. Okay, so multiplying out that double bracket there, I'm going to get 35 plus 3x times 3x is 9x squared. 3x times 1 is 3x. 1 times 3x is 3x. 1 times 1 is 1 minus 8x squared plus 6x. Okay, so now we can collect like terms, can't we? So I've got 9x squared minus 8x squared. So that's going to give me x squared. Okay, and then I've got 3x, 3x, 6x. That adds up to 12x, isn't it? Plus 12x. And I've got 35 and 1. So that adds up to 36. Okay? Right, so I've got x squared plus 12x plus 36. Now, can you factorize that? I've got a number 36 on the end here, haven't I? 36 on the end. What are the factor pairs of 36? 36 has got factor pairs 1 and 36, 2 and 18, 3 and 12, 4 and 9. Any more? Yep, 6 and 6. 6 is a square number, isn't it? Okay. Now we want to have a pair that adds up to 12, don't we? So we can get 12 in the middle. So which pair of these adds up to 12? it's going to be this one, isn't it? 6 and 6 adds up to 12. So what I've got here then is x plus 6 times x plus 6. Okay, so I've got something times itself. Another way of writing that is x plus 6 all squared then, isn't it? So I've shown that that long complicated expression is just the same thing as x plus 6 all squared. So if x is an integer, then x plus 6 is also an integer. Integer is just a whole positive or negative number. And x plus 6 all squared must be a square number. Okay, because if I square an integer, I'm going to get a square number, aren't I? Okay, done. Question 22. Liam is trying to remember a 3-digit code. He knows the rule that the first digit is a cube number, the second digit is a factor of 16, and the third digit is an odd number. Liam tries at random a code that matches the rule. Work out the probability that this is the correct code. Okay. Well, let's think about what possible numbers he could pick from. So the first digit is a cube number. 1 cubed is 1. 2 cubed is 8. 3 cubed is already too big, isn't it? It's 27, so that's not a 1-digit number. So the first digit is either a 1 or an 8, isn't it? Okay, the second digit is a factor of 16. So numbers that are factors of 16 are 1, 2, 4, 8, and that's it, isn't it? All the other ones are bigger than, are not 1-digit numbers either. So it's 1, 2, 4, and 8. And then the third digit is an odd number. So odd numbers 1, 3, 5, 7, and 9. Okay. So if he picks a number at random that matches the rule, he's got 2 choices for his first digit. He's got 4 choices for his second, and 5 choices for his third. So the probability that he picks the right one for the first digit is going to be 1 out of 2, isn't it? Okay. The probability that he picks the correct one out of those 4 possible choices for the second digit is 1 out of 4, and the probability that he picks the third digit correctly then is going to be 1 in 5. Okay. Now he needs to pick each 3 correctly, so he needs to pick the first one correctly, and the second one, and the third one. And in probability terms normally means multiply. So we're going to multiply those numbers together. So the probability that he is correct in guessing the code is going to be a half times a quarter times a fifth. Okay, so a half times a quarter is an eighth times a fifth. That is that's 1 over 40, isn't it? So 1/40. Question 23. A ship sails from P to Q and then from Q to R. Q is 12 miles from P on a bearing of 080. R is 28 miles from Q on a bearing of 155. Work out the direct distance from P to R. Okay. So let's just follow that through. A ship starts at P then, doesn't it? So it's starting here at this point here. Okay, it's going to go then along this route. It's going to then go along this route to Q, and then it's going to change direction and it's going to go down here. Okay, and it's going to end up at R. Now we want to know the direct distance from P to R. So if I can add that in as an extra line, P to R, we want to basically work out the length of this line here, don't we? Okay. Now, so we want that distance. I'm going to call it, well, let's call it Q, because it's opposite angle Q, or like vertex Q over there. So I'm going to call this one over here P. P is equal to 28. And I'm going to call this one R. R is 12. Okay. So I've got 2 sides of a non-right-angled triangle, and I want a third side. Now, if I knew one of the angles, preferably that one there, then I'm going to be in a position that I can use the cosine rule then, isn't it? Because the cosine rule is about 2 sides and an included angle needed to find a third side. So I know the 2 sides, R and P, 12 and 28. I can probably find Q, the angle, from the information that's on the diagram already, and then I can use that to find Q using the cosine rule. Okay, so what is that angle there at Q then? Okay, so first off, let's have a think about what the angle here is. Okay, so I know that this one over here is 80. Now it relates to this one. They're not equal to each other, are they, up here? But they're related to each other. We call those interior angles, don't we? Okay, so this one here is co-interior to the 80 degrees. So co-interior angles sum to 180. So that one there is going to be 180 minus 80. It's going to be 100 degrees. So that's 100 degrees in there. Okay, and then I've got angles that are meeting at a point. So I've got 100, 155, and that angle Q meeting at a point. So angles at a point sum to 360. So Q plus 100 plus 155 should be equal to 360, shouldn't it? Okay, so 100 plus 155, that adds up to 255. So Q plus 255 is equal to 360. So then Q then is going to be 105 degrees, isn't it? So that is 105 degrees. Okay, so now I'm going to be using a cosine rule in triangle PQR then. Okay, so in triangle PQR, I want to find Q using the cosine rule. So Q squared equals P squared plus R squared minus 2PR cos Q. So you should be able to take the general form of a cosine of the cosine rule and kind of modulate it to whatever letters you've been given for your question. Okay, so I'm switching all the A's and B's and C's around to P's, Q's and R's. Just following the pattern really. It kind of starts off a little bit like the Pythagoras theorem, and then you've got this minus 2PR, so the P and the R are the same as the P squared and the R squared, and then cos Q, and the Q is always the same as the letter you've got on the other side of the equal sign. Okay, that's kind of how I remember it. So let's sub in what we know then. So that is equal to P squared. P is 28, so 28 squared plus R squared. R is 12, 12 squared, minus 2 lots of P, which is 28, Q, which is 12, and cos Q, which is the cos of 105. Okay, so now I need to evaluate that. So I think I'm just going to tap it all into the calculator. If they were smaller numbers, I might kind of just do a little bit more in my head first before I tapped it in. But I don't know what 28 squared is, so I'm just going to tap it all in. So 28 squared plus 12 squared minus 2 times 28 times 12 times the cos of 105. Now that comes out to 1102 to four significant figures. Now that you imagine that where Q is 1102, you know that's much too big, isn't it? It isn't 1102. Remember we found the Q squared here, so remember we're going to have to then square root this to find Q. So Q is going to be the square root of 1102. So root answer, that comes out to be 33.2. 33.2. I suppose that's in miles, isn't it? Now that does look a little bit better in my diagram. So if I imagine instead 33.2 miles here, that looks about right in that triangle, doesn't it? It's like the longest side of that triangle, so it's a little bit more than 28. Yeah, 33.2 looks good. So I'm pretty sure that is good, and it's the right answer. So I've worked out the direct distance. I don't need the angle or anything. I just want the length of the line. Okay, I'm done. Question 24. The flight of a plane was in 2 stages. The table shows information about the flight. So the first stage of the journey, the distance travelled was 731 miles, the speed was x, and the time in hours was 731 over x. And then in the second stage, distance was 287, speed was x over x minus 24, and time was 287 over x minus 24. Okay. In total, the flight lasted 2 hours. Work out the value of x. Okay, so most of that table we don't need then, is it? The distance and the speed have been used to calculate the time. Time is equal to distance divided by speed. So you can see the first two numbers here and here just end up being here, and the same with the second one. Okay, so they've just used kind of the DST triangle to work those out. So actually we don't need to know that bit at the beginning. All we need really is the last column of this table, this bit here. We know that the total the flight time lasted 2 hours. So what we need to do is to say, well, I've got 731 over x, and I've got 287 over x minus 24, and I know that this is equal to 2 because it's 2 hours. Okay, so what we then need to do is work out what x is from that. So what we've done here is we've formed an equation in x, and this equation so what we've done here is we've formed an equation in x, and that equation involves some algebraic fractions that we're going to have to deal with. Okay, so first off, when you're adding fractions together, you need a common denominator, and we're going to form that common denominator by multiplying x and x minus 2 together. It's a bit like if you had like halves and thirds, then the common denominator would be 2 times 3, it would be 6, wouldn't it? So here I've got x and x minus 24, so the common denominator is x minus 24 in the same way. Okay, so how many times does x go into x times x minus 24? It goes in x minus 24 times. So I'm going to have to take that 731 and multiply it by x minus 24, and then that's going to be added on to how many times does x minus 24 go into x lots of x minus 24 times? It goes in x times, so that's going to be 287x on the top. Okay, now if you find fractions algebraic fractions really difficult to follow, just write some fractions down and have a think about what you do with those. Algebra is just generalized arithmetic, so whatever you do with numbers, you just do the same thing with algebraic terms. So just try that out. All right, so then on the top here, I've got 731 lots of x minus 24. So I'm going to just multiply out that bracket there. So I'm going to get 731 lots of x minus, what's 731 times 24? 731 times 24, that's 17,544. 17,544, okay, and then plus 287x, and that's all over x minus 24, okay, and that's equal to 2. Okay, now the next thing I'm going to do is I'm going to cross multiply this up here. Okay, just multiplying through both sides with x minus 24. So that's 1018x minus 17544, and that is going to be equal to 2 lots of x minus 24. Okay, so then I got to do some FOIL on the, well, then I've got to remove the brackets on the right hand side there, haven't I? So that's going to give me, on the right, I'm going to get 2x squared minus 48x. And on the right, I've still got 1018x minus 17,544. Okay, now I want to try and get everything on one side, and it makes sense to collect it on the right hand side because that's where my 2x squared is positive. So I'm going to subtract 1018x. I'm going to add 17,544 to both sides. So these two things here are going to budge over to the other side, aren't they? They're both going to go over there. So that's going to give me 2x squared, and then I've got minus 48x, and I'm going to be taking away another 1018x. So 48 and 1018 together make 1066. So that's going to be minus 1066x. And then I've got plus 17544, and that's all equal to 0. So now I've got a quadratic, haven't I? Okay. Now notice I've got 2x at the beginning, so I can make things a little bit easier for myself just by dividing through by 2. So that's going to give me x squared minus, what's half of 1066? That's 533, isn't it? So 533x plus half of 17,544. 17,544 divided by 2, that comes out to be 8,772. And that's equal to 0. Okay? Right, so now ideally I'd like to be able to factorize this, but I've got a very big number there, haven't I? I've got 8772. So to break 8772 down into all its factor pairs, that's going to be a pain. But I really don't want to do the formula because that's even more of a pain. So how can I make this a little bit easier for myself? Well, I could express 8772 as a product of its prime factors, because I've got a key on my calculator that does that. So 8772 shift fact. So that's 2 squared times 3 times 17 times 43. 2 squared times 3 times 17 times 43. Now this gives me some factor pair choices then, doesn't it, that I can possibly make. So if for instance I picked that 17 in there, that looks about the right sort of size, and I did, well, what's 8772 divided by 17? Then that goes with 516. That's quite close, isn't it, to 533 I'm seeing in the middle. So I'm thinking that's probably my my best bet. So 17 times 516, so if I did 8772 and I wanted to know its factor pairs, then 17 goes with 516. I think that's going to be my choice. So it's positive on the end and negative in the middle. That means my brackets have both got a minus sign in them. One of them is going to be 17 and one is going to be 516. Just double check, does that add up to 533? Yes, it does. So awesome. So x minus 17, x minus 516 seems to work. So then that tells me then, and that's equal to 0. So that means that x is equal to 17 or x is equal to 516. Now, do both those solutions actually work though? Now, if x is 17, if you have a look here, if you have a look at x minus 24. Now, if x was 17, then x minus 24 would be a negative number, which means our plane would be flying backwards, and that is not a good look for a plane. So I don't think this one is a possible solution. I'm going to say not possible, as x minus 24 is less than 0. Okay, so that one's that's not a possible solution. So the only solution is that one, x is 516. Therefore, x equals 516 what? Miles per hour. Okay, I am done. That was quite hard work. Question 25. The equation of a curve is y is equal to x squared plus 14x plus 52. By completing the square, work out the coordinates of the turning point. You must show your working. Right, so if I want to take y equals x squared plus 14x plus 52 and rewrite it in completed square form, I take this number here, the coefficient of x, and I halve it, don't I? So 14 divided by 2 is 7. And that is then the thing that I use in my bracket. So y is going to be equal to x plus 7 all squared. That is going to be my replacement for x squared plus 14x. But x plus 7 all squared is actually x squared plus 14x plus 49. So I've introduced 49 more into my equation I had to start with, so I need to take it away. Plus I've still got that 52 there left over from earlier that I didn't use. Okay, so then just tidying that up, y is equal to x plus 7 all squared minus 49 plus 52 is plus 3. Okay, so when is this equation at its least? It's at its least when this bracket here is 0. So then we've got 0 squared, and that occurs when x equals negative 7. So turning point, it's going to be when x is minus 7. Now if x was minus 7, that bracket would disappear and it would just leave you with 3. So y is equal to 3. Okay, so then the coordinates then are negative 7, 3. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.